This lecture is going to have to deal with solutions and dilutions, and we hope to be able to understand the units of concentration and to use these to be able to determine the amount of a solute present in a solution, and then also to be able to calculate the concentrations of a solution after it has been diluted. So first, we need to talk a little bit about solutions and compositions of solutions. One of the more common problems in chemistry, and we've already seen this once in lab, is this idea of how much stuff is present in a solution. We can think about whether that's how much lead is present in drinking water, how much coronavirus is present in wastewater. There's a lot of questions that deal with how much stuff. And when we talk about how much stuff, we usually are talking about concentration, how much stuff is present in a solution. The most common unit of concentration for chemists is molarity. So molarity, we'll get to in a second, a little bit more about solutions. We can say, as a reminder, we talk about a solution is made of two parts. A solute, that's the thing that's dissolved. Often solutions have more than one solute dissolved. And the solvent is the substance that's present in excess. Most of the time we're dealing with an aqueous environment, so water is often our solvent, and everything dissolved in the water are our solutes. When we talk about concentration in chemistry, a lot of the times we're going to be dealing with molarity. So molarity gets the abbreviation capital M, and molarity is defined as the moles of the solute divided by the volume in liters of the solution. So moles per liter. And as I said, when we talk about molarity, we use a capital M to symbolize it. So anytime you see a capital M, that's always referring to moles of solute divided by liters of solution. So for example, we can look at a problem. In this problem, we're told that 0.4 moles of sodium chloride are dissolved in half a liter of water, and we're asked to calculate what is the molarity. So we can go ahead and set this up, and a little bit more about how chemists will express things. I'm going to set this up as sodium chloride in brackets is equal to, and anytime you see something in brackets, that's referring to the concentration of that substance. So this is really saying the molarity of sodium chloride is equal to, and now we can go ahead and put our numbers in to say molarity is moles per liter, so 0.40 moles divided by 0.50 liters, and we end up with 0.80 molar. So that's how we'd express that, 0.80 molar. In another problem we can look at, we can say what is the molarity of a solution if 2 grams of sodium chloride are dissolved in half a liter of water. Now notice this is a slightly different problem than we just did, but it just because it's one extra step. Here we are given grams of sodium chloride. So the first step of this is going to be convert 2 grams into moles, and once we have the moles, it's going to be the same as up here where we divide moles by our volume. So we're going to first convert grams to moles, and we're going to 2 grams divided by our molar mass, which we look up from the periodic table, 58.5 grams per mole, and we get 0.034 moles of sodium chloride. And now we can go ahead just like before and say the concentration of sodium chloride is equal to 0.034 moles of sodium chloride divided by that 0.50 liters, which ends up being 0.6068 molar. One of the more important uses of concentration, and molarity in particular, is that if we know a concentration of a solution, so if we're given a molarity, moles per liter, we're often asked if we add X liters of a solution, how many moles of a substance do we deliver? And if we think about that type of problem, if we know a concentration, moles per liter, and we know how many liters of solution that we use, if we were to multiply moles per liter times liters, our liters cross off and we're left with moles. And one of the most important things we can remember from general chemistry, if you go on in chemistry, biology, or other labs, is molarity, or concentration, times a volume is always equal to the number of moles. So if you know the concentration of a solution and you multiply by the amount of solution you used, the volume of it, you'll end up figuring out how many moles of that substance you delivered. Here's a problem we can go through. Hydrochloric acid, HCl, is sold as a 12 molar solution. So we could be presented a problem where we ask, if we have 300 milliliters of this solution, how many moles of HCl are present? So how many moles of HCl are present in 300 milliliters of a 12 molar solution? So to solve this problem, what we would go ahead and do is we'd start off with the 12 moles per liter of HCl, what we're given, the molarity of HCl, multiplied by our volume. Notice our units are liters and milliliters, so I'm going to have to add a conversion factor to cross out my milliliters, so 1 liter per 1,000 milliliters. So our units cross off, and we're left with 3.60 moles of HCl. So in this volume of solution, this is how many moles of HCl were present. So the other thing we want to learn how to do is to calculate the concentration of a solution as it's diluted. And so we can use what's known as the dilution formula here. And so dilution, right, is the process of lowering the concentration of a solution by adding more solvent. So if we have some solution, we add more water to it, what is the final concentration of that solution going to be? And so here's the dilution formula. M1 V1 equals M2 V2. The M's are molarity, so initial molarity times your initial volume is equal to the final molarity times the final volume. So we can go through an example of how this works. And if we notice in this formula, concentration times volume equals moles, concentration times volume equals moles. So the reason why this formula works is it's the same number of moles. So the number of moles of a solute is equal to the same number of moles of the solute. So let's go through an example. What is the concentration of a solution prepared by removing 1 milliliter of a 0.80 molar solution of sodium hydroxide and diluting it to 100 milliliters? So again, what are we doing? We're starting off with a solution that's 0.80 molar. We're going to take 1 milliliter of that out. We're going to put it in a new beaker, and then we're going to dilute that beaker to 100 milliliters. So we took a certain amount out. That gives us a certain number of moles. That number of moles goes into a new vessel, and we're going to dilute it so the concentration will change, but we're to have the overall same number of moles. So we can look at that and say our stock solution, if you will, our concentrated solution, M1 is 0.80 molar. V1 is that 1 milliliter that's removed. We're taking 1 milliliter of this out, right? And that 1 milliliter out via pipette is put into a new vessel. So however much number of moles we remove from this pipette out of the stock and put into our new vessel, that's the total number of moles in that new vessel. After we add this number of moles, we're going to then add more water. So we're not changing the moles of solute, we're just changing the concentration. So how much are we diluting it to? We're diluting it to 100 milliliters, so that's V2. So you can see in our formula, we know M1, we know V1, we know V2. So we can say M1 V1 equals M2 V2. Initial molarity is 0.8 molar. Our initial volume, I converted to liters, so we have 0.001 liters. There's the 1 milliliter. Our final volume is 0.1 liters or 100 milliliters, and so we can divide that to the other side. And here it is worked out, and so our final concentration, M2, is 0.0080 molar. And notice that should make sense. It is a less concentrated solution than we started with. We started with 0.8, we ended up with 0.008. Now in chemistry, molarity is not the only unit of concentration. That's the most common one. molarity, moles of a solute per liters of solution. Occasionally you'll see what's known as molality, which is moles of solute over kilograms of solvent. Sometimes we're presented with what's known as the mole fraction, the moles of solute over the total moles of solute plus moles of solvent. And sometimes we're dealing with percent mass, the mass of the solute divided by the total mass of the solution. So those are a few of the common units of concentration, although most of the time we will deal with molarity. We've seen in lab a weight percent or mass percent, and we've now also seen a volume percent. Thank you.